This video will cover cross sections. All right, so let's get started with problem number 1. So let's start by graphing these 3 different functions. So y equals x is going to be our diagonal through 0, 0, so that triangle or diagonal line there. Y equals 0 is going to be horizontal, our x-axis. And then x equals 4 is a vertical line through the x-axis of 4. So this blue area here is what we're talking about. So that's the base of a solid. And then what's going to happen is we're going to have these squares that are sticking out perpendicular to the x-axis here, so vertical lines there. That's the base of the square, and then it sticks up towards us, like out of the paper, okay? We want a bunch of squares that each change base throughout this as it sort of follows the path here, okay? So that is the length of one side of the square. So let's find the area of just one of the squares. So area equals s squared, the length of the side. And so in this problem here, our length is going to be the top minus bottom, just like we did with our disc and washer problems. So top minus bottom is going to be my red, which is x, minus the bottom is y equals 0, and we're going to square that. And in this case, that's just x squared, right? So that's the area of every square. If we want to find the total volume, we need to add up all of these different areas. So what we're going to do is the integral, that's going to sum up all of these areas, of x squared dx. Because again, x squared is the area of one square. And then our boundaries are going to go from x equals 0 to x equals 4. And then we're going to throw this in our calculator. All right, so I'm going to go to Math 9 to get my integral. I'm going to hit 0, go up, make my boundaries 0 to 4, and then we're just going to type x squared, and it automatically in mine has dx, but you would need to put the x in most calculators. And we should get 21.333. All right, so this problem, we want the base of a solid to be in the first quadrant, enclosed by y equals x squared and 7, so let's go draw those. So because it just said the first quadrant, I only care about the right half of this. So I'm just going to focus on the quadratic to the right side of the y-axis, and then y equals 7. It's going to be here. So the first quadrant of that is going to be this blue section here. So now it says if all cross sections perpendicular to the y-axis. So that means we're going to do this dy, and we've got this distance here, perpendicular to the y-axis. So the area of just one of these triangles is going to be the formula square root of 3 over 4 times s squared, where s is one length, one side of this triangle. So this, according to our graph over here, s is going to be the distance between the y-axis and our red curve. And remember, when this is with respect to y, dy, we're going to turn our paper to the left and think of top minus bottom. So in this case, the top minus bottom is going to be red minus 0. And so our red is currently in terms of x. We need to solve that so we have x equals, so it's going to be the square root of y minus 0, our y-axis. So that was kind of tricky here, but what we did was we needed this to be in terms of y because when we go to do our actual integral, it's going to be dy. So everything needs to be y variables. So let's go ahead and do our integral, our volume now. So the volume is going to be the integral of this business here. So this is going to be our whole area of each equilateral triangle. And so maybe I'll simplify this by squaring that y. So we'll just have the square root of 3 over 4y dy, and then we need to figure out our boundaries. So remember, we're going y values. So we're going from 0 up until y equals 7. And then we'll throw that in our calculator. So remember, in our TIs, we're going to do this all with x, even though we wrote down y values. And I'm using alpha y equals to get the fraction, and I'm just going to type it in as we see it, but with x's. 10.609. So problem number 3, we want to let the base of a solid be the first quadrant region enclosed by these two functions if all cross-sections perpendicular to the y-axis are semicircles. So perpendicular to the y-axis tells us this is going to be a dy problem, and semicircles kind of behave a little bit funky, so we'll see what that looks like when we get to it. But first, let's start by graphing these two functions. So y equals x squared, and again, we're just looking at the first quadrant, so I don't need to put the left half of this. And then y equals 4 is going to be our horizontal line. So since we just care about the first quadrant, that's going to be this area here. We want cross sections perpendicular to the y-axis, and they are semicircles. So that means we're going to have sort of this little shape sticking out of the, like sticking out towards you from your paper here. So the area of a semicircle is going to be 1/2 pi r squared, because it's semicircles, we only need half of that normal pi r squared. And the tricky part with this problem is that this length here is actually going to be the diameter of our semicircle, because if it's sticking up, that's that full length. So we only need half of that diameter in order to calculate our radius here. So the diameter is, if we turn our paper to the left, going to be this pink function minus 0, because that's going to be our y-axis. Here's the problem. Our pink function is in terms of x, so we're going to need to solve it for terms of y. So we need to solve for x in order to get it in terms of y. And so our radius is going to be that pink function, square root of y, over 2, because again, we just want the radius, and the square root of y is actually our diameter, minus 0. And so the minus 0 isn't really doing anything. So if we're going to simplify this, we'll have square root of y squared is just y. 2 squared is going to give us a 4. So we will have y over 8 pi, or if you wanted to look at it as 1/8 y times pi, we can do that too. So that's going to be our area of one semicircle. So now let's go back and find our overall volume. So the volume here is going to be, with respect to y, because this is perpendicular to the y-axis, and our area of one semicircle, that's what this is, the area of just one of the semicircles, is represented as 1/8 y times pi. And then let's check our boundaries. Remember, y values here, we're going from 0 all the way up to y equals 4. And so then we'll type this in our calculator. And we get pi, or 3.142. All right, so this last problem here, we want to let the base of a solid be a circle, and all cross sections are perpendicular to the y-axis, so that tells us dy, and they are squares. Let's find the volume of that solid. So let's start by graphing. All right, so to graph a circle, x squared plus y squared equals 4. That's going to be centered at 0, 0, and the radius is 2 because our equation is equal to r squared. So here's, yikes, a roughly drawn circle. Doesn't really matter that much. And the inside of this is the area covered. Our cross sections are sticking out, and they are squares perpendicular to the y-axis. So one of these lengths here, that is our side. Let me make that easier to read. Okay, So now let's talk the area of just one square. So the area of a square is side squared, s squared. Our area is going to be the distance from the right to the left, because we would turn our papers left, so we would have this minus this. So that means we kind of need to split this circle in half. So what we're going to need to do is take our circle equation and solve it for x. So we'll have x squared equals 4 minus y squared. So then x equals plus and minus 4 minus y squared, or the square root of 4 minus y squared. Because the right half, this is going to be the positive version, and the left half will be the negative version of those square roots. So our side length is going to be the positive 4 minus y squared minus negative square root 4 minus y squared, all squared. So this is kind of crazy. We've got the right minus the left, because if we turned our paper to the left, we would have that positive side minus the negative side. And so let's simplify this here. That would become a plus in the middle. So now I really have just 2 times the square root of 4 minus y squared, and that's going to become 4 times 4 minus y squared, no square root. So then I get 16 minus 4 times y squared. And this 4 comes from the fact that I had to square the 2 because it's not in the square root, but then the square root just cancels out when you square it. So one of these sides has an area, or one of these squares has an area of 16 minus 4y squared. So we're going to go back and actually calculate our volume now. So the volume is going to equal one of these squares dy, because it's perpendicular to the y-axis, and then our y values go from -2 to +2. So we'd throw this in our calculator. And we get 42.667, and that's it.